Hey everyone, today I'm going to talk to you about the geometric mean. Simply put, the geometric mean is the square root of the product of two numbers, and it can kind of be justified by this proportion here, a over x equals x over b. So we're only dealing with, I guess, two pieces of information, whereas an ordinary proportion, you have three pieces of information. You have one piece you're solving for. Well, here we're solving for one piece, but we're only given two pieces of information. So when you cross multiply, you get x squared equals a times b, and then when you square root both sides, you get the formula for the geometric mean, x equals square root of a times b. So that's what I'm going to do for these four examples. I'm just going to square root 4 times 4, which is square root of 16, or just 4. I mean, that one you should be able to tell by looking at, because the square root of 4 times 4 will just be 4, because you're squaring it. You're squaring 4, so opposite of a square is the square root. Okay, 4 times 6. All right, 4 times 6 is the square root of 24. That is not a perfect square. All right, so when you get things that are not a perfect square, and by perfect square I mean square root of 16 was a perfect square. It gets a whole number. Square root of 24 doesn't get a whole number. So we need to try and simplify it. And what I mean by simplify it is you need to think of factors that are perfect squares. So like 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. Okay, so I know that 24 is 6 times 4. I already know that. So the square root of 4 is 2. And the square root of 6, oops, not 2. The square root of 6 remains the square root of 6. So this is the preferred way to represent the square root of 24. And again, I just took the square root of 4 and wrote the 2. So it's no longer under the radical once you take the square root of it. And then the square root of 6 stayed behind. That is preferred over getting the decimal approximation. So from here on out, anytime we get a radical that's not a perfect square, we're going to see if we can simplify. Now, they don't always simplify. Sometimes they just stay the same, but they usually do. Or often do, I should say. 6 times 9. Okay, that's 54. Well, remember, 54 is 6 times 9, and 9 is a perfect square. And that is the largest perfect square that goes into 54. So the square root of 9 is 3. And the square root of 6 stays behind. So that's the answer. Okay, so if you're confused by any of this, just know that these are equivalent statements. The square root of 54 is equivalent to 3 square root 6. You can type that into your calculator, and you'll get the same thing. And then this one is actually really simple, just maybe trying to throw you off because there's a fraction. Square root of 1/2 times 2. Well, what's half of 2? That's 1. What's the square root of 1? 1. 1 squared is 1. Square root of 1 is 1. Everything's easy when you're just dealing with 1. All right. Now, how does the geometric mean apply towards geometry? Well, in the last chapter we talked a lot about similar triangles. And so right here, we have the triangle ACB, and in it they have the altitude CD, and so with this altitude it has now formed two other triangles. It's formed triangle CDB, and then it's also formed triangle like CAD right here. So now I have three triangles. I have the large triangle in green, I have the smaller one in red and blue. Okay. All those triangles are similar to one another. So, a lot of times, a lot of what we've done throughout the years is solving for one piece of missing information. So I'm just going to, something will be labeled on these triangles, okay? And something, we'll be looking for something else. So rather than needing three pieces of information, we're going to use the geometric mean, property of geometric mean, and only use two pieces of information to figure it out. And so, excuse me, here's triangle CAB plucked out from this image. and it says that you can figure out h. What is h? You can figure out h, the altitude, by multiplying x, cross-multiplying x and y. So that is the small base and the longer base, or see, it says shorter leg and longer leg. CAD, that is going to be this medium triangle in red. That's saying you can figure out B, the hypotenuse of CAD, by cross-multiplying the hypotenuse by itself and then cross-multiplying the total base. Or I call this the total base, C, the little c, because it's the base of these two smaller triangles, but it's also the hypotenuse of the triangle ABC. And then lastly, we could figure out y, the excuse me, sorry about that. Y is the little base, or the medium-sized base. And we figure that out by cross-multiplying the hypotenuse of that triangle, of triangle CDB, cross-multiplying by that itself, and multiplying y by the total base, or the big hypotenuse. Okay, so that might all sound confusing, but if you look at it, see how it says h times h, b times b, a times a. That's all geometric mean stuff right there. See, this one's x times x. So that's how it's going to apply to geometry. All right. Once you get the hang of these patterns, you don't really need to make the proportions anymore, in my opinion. So what I'm going to do is I'm just going to set up the first two, and then once we get the hang of it, we don't really need to do that anymore. But see, x is the altitude, and 1 and 3 are my bases. So the one that deals with my two bases and the altitude is this one right here with the x, y, and the h. So it just says I put the base over the altitude equals the altitude over the other base. So I'm going to do that. The base over the altitude equals the altitude over the other base. Now I'm going to cross multiply, and I get x squared equals 3 times 1 is 3. How do you get rid of a square? We square root. So x is going to equal the square root of 3. Now, what's the easier way of doing this? Because remember, the geometric mean was defined by this proportion, but we could also just use this formula right here. So multiplying two numbers and take the square root. What two numbers am I multiplying? The two bases. So I'm going to multiply, I'm going to say x equals the square root of 1 times 3, which is square root of 3. And that does not simplify. We're going to leave it as square root of 3. So that's kind of the easier way of thinking about it when you're looking for the altitude. So I'll use that same ideology. I'm looking for the altitude here. I'm just going to multiply the two bases. All right. That's square root of 10, and that's not going to simplify either. Now let's figure out the y. Well, if I want to figure out the y, that's going to be the tiny hypotenuse. So that would be, if I were to use this picture, that would be the letter B right there. So I'm going to do C over B. In other words, the big base over the hypotenuse equals the hypotenuse over the little base. So I'm going to use the little base and the big base. So what's the big base? The big base is 7. Okay, so I'm going to go y over 7 equals, I'm going to go 2 over y, where I'm using a y twice. You're always going to want to, when you're setting up the proportions, you're always going to want to cross multiply times the variable. So, because you're always going to want to get y squared or x squared or z squared. So y squared equals 7 times 2 is 14. So y equals the square root of 14. Now, let's simplify our way of thinking about this. Well, if I'm looking for the little hypotenuse, I'm going to use the little base and then the total base. So I'm just going to go y equals the square root of 2 times 7, which is square root of 14. Okay, so that's the easier way of explaining things. And then I'm going to do a proportion the same way since z is another hypotenuse. So if you look at this, it's the same kind of proportion where you use the base that's associated with it. So 5 is the base associated with z. And then I'm going to use the total base 7. So z is going to equal, well, let's do the proportion first. So z over 5 equals 7 over z. And so that's z squared equals 35, which means z equals the square root of 35. Now, how do I get right to that without having to do the proportion? Again, I'm going to use the base with the z, so that was 5, and then the long base, so that was 7, and just throw it under the square root of 35. And all these answers, none of them simplify. Square root of 35, square root of 14, square root of 10. I'm just going to leave them as that. Now, let's see here. What do we have going on here? Okay, I have 1 as a little base, 8 as another base, so the total base is going to be 9. And x is a little hypotenuse, y is a little hypotenuse, and z is an altitude. So when you're dealing with the hypotenuses, you're going to just do, let's just skip the proportion stuff. I'm going to use the base with the x and then the total base. Well, 1 times 9 is 9. The square root of 9 is 3. All right. Now let's figure out y. The base with the y is 8, and the total base was 9. So that's 72. Now, can 72 simplify? Yes, it can. The square root of 72 is 36 times 2. So I know the square root of 36 is 6. And the square root of 2 stays behind. So this and this, they're the same thing. But I want you to write the answer as that. Okay? Yeah, show your steps. By all means, please do. I think it'll help you out. Just try and think. I knew that 36 was a factor of 72. It helps to know your perfect squares. All right. I'm going to figure out z now. Well, z was, I just used the two smaller bases, 1 and 8. So I'm going to go 1 times 8. Okay, that's square root of 8. Can that simplify? Yes, it can, because square root of 8 is 4 times 2. And the square root of 4 is 2. All right. And the square root of 2 stays behind. So yeah, this is the final answer. The square root of 8 is 2 square root 2. Okay, so I figured out x, y, and z. Okay, we got 3 left. All right, this one looks like we're going to have to go backwards a little bit. Because I'm given the altitude, and I'm trying to figure out y, the base associated with that. So if I were to set it up just multiplying, it would look like the square, it would look like this. It would look like the square root of 3 equals the square root of y times 1. And so you can think, well, y times 1 is just y. And so y must be 3 because it's going to equal square root of 3. So you can figure it out that way. Or you can just go back to how the proportion was set up. Okay? So the proportion was set up something like, oh, that was the bell. Square root of 3 over y equals y over 1. So when I cross multiply, I get y times y. You know what? Just yeah, I made a mistake. Let's see here. Trying to back this up. Okay, where am I at? Sorry about that. Rather than do an edit, just keep this thing raw. Okay. Okay. Sorry about that. So if I go y over square root of 3, then it's going to equal square root of 3 over 1. I always go this to that, and then that to that. That's how I did it, and I was doing it backwards and confused myself. So when you cross multiply, square root of 3 times square root of 3 is just 3. Y times 1 is just y. So 3 equals y. So whatever's your preferred way of solving it, that's the way I want you to do it. Let's figure out x. Okay, x's can be figured out now because if y equals 3, then this whole base is 4. So remember, x, you just use the base that's with it, which is 1, and then use the total, which is 4. 4 times 1 is 4. The square root of 4 is 2. All right, so number 5. I got the altitude 2, so I'm going to go 2 over the other base 2 equals 2, the altitude, no, I'm going to go the base 2 over the altitude 2 equals the altitude 2 over the base x. And so if 2 over 2 equals 2 over something, well, you can cross multiply if you want. 2 times 2 is 4. 4 divided by 2 is 2. So x equals 2. Also, 2 over 2's got to equal 2 over, well, 2. All right. So if x equals 2, that means this whole thing is 4. And look, 2's a base, 2's a base, 2's the altitude. Z and y have to be the same thing because they have the same base and the same altitude. 2 of the legs are the exact same, so the third leg's not going to be any different. So I'm going to solve z and y at the same time. So z equals the square root of 2 times 4, the base associated with it, and the longer base. So 2 times 4 is 8. Okay, and remember, the square root of 8, the factors of that were 4 and 2. The square root of 4 is 2, and the square root of 2 stays behind. So this is the answer for z and y. Okay, last one. Okay, if this is 2 and the whole thing's 6, then this one's 4. So the y is going to equal the square root of 2 times 4, which we've already done. That's 8. But instead of writing the square root of 8, I'm going to write 2 square root 2. All right. So x is going to equal the square root of 2 times 6, which is 12. And 12 is the square root of 4 times 3. And that's important to know because 4 is a perfect square. So the square root of 4 is 2. Square root of 3 stays behind. So that's x. And then y. Y is going to be square root of 4 times 6. The square root of 4 is 2. So it stays behind. I mean, that goes in front. And square root of 6 stays behind. And that's it. Goodbye.